Should we ask the people on the chat if they can see us?
Good evening, viewers, and welcome to Space Oddities. Hope you're all well. Sorry, we've had a couple of technical issues, but we seem to be okay now. Because yep, we're okay. We're good to go. Good evening. How are you all? We hope you're all okay out there in YouTube land. And welcome to Space Oddities. And I'd like to say good evening to the panel. Good evening, panel.
Hello. Hello.
Good evening again.
Hi there.
Yeah, and we're going to carry on tonight with our usual mix of space news and chat and all sorts of interesting things. Before we start, though, we have a rather important announcement we're absolutely thrilled to share with you. When we started Space Oddities Live after the sad demise of Astro Radio, we always said that we were going to move things forward and expand and do lots of interesting things that we had in mind. And we're delighted to announce the first step of this. We are now working in association with Rother Valley Optics, who are a major supplier of telescopes and optical equipment in Rotherham in the north of England. So if you're in Rotherham, go along and have a look. They have a huge range of telescopes at incredibly competitive prices, and we'd be delighted to work with them to bring you content in the future. So just give me 1 second. And I'll show you exactly what this is all about. So Rother Valley Optics, as I said, are based in Rotherham, and they are going to be sponsoring us very kindly. And you can find them at that address. Their website is www.rothervalleyoptics.co.uk. Go along and have a look. And as part of this, the first part of this sponsorship, we are announcing a competition today to win this telescope, the Skywatcher Heritage 76, which is a telescope for beginners. But we will be giving this away in a competition that we will announce the details of later tonight. Really thrilled to be doing this. We will be having a monthly competition for you all to enter. And there will be a similar prize or even a better prize each month, and we're delighted to be working with Rother Valley Optics to deliver this. So stick around, because a bit later I'll be announcing details of the competition, how you can enter, and all of that. And it's a lovely prize. So without more ado, let's just move on. Firstly, I'd like to talk a little bit about the Juno mission to Jupiter. Juno, as you may know, is a spacecraft that's been orbiting Jupiter since 2016. It's given us a completely revolutionary view of the giant planet Jupiter, giving us things that we haven't seen before. But the main aim of the Juno mission really is to understand what's going on inside Jupiter. What's the interior of Jupiter like? What's actually under the clouds? And this is something that is very difficult to ascertain, but Juno has the technology to answer these questions, and has indeed answered some very interesting questions. Just like to show you a couple of the latest images from Juno. Oops. These are two of the latest images from Juno. An amazing, yes, Daz?
We got no images, Andy.
You've got no images?
No.
Yeah, we didn't see any images when you were presenting earlier on as well.
Having some real technical problems tonight. 1 second, just give me 1 second. Let's just go back one then. Okay, let's try this. Right, can you all see this?
Yeah, it's coming on.
There we go.
Yeah.
There we are.
There we go.
I don't know what happened there. So this is Juno, the spacecraft orbiting Jupiter. Here are a couple of its latest images, which are, as you can see, absolutely fabulous. And the one on the left, well, in fact, they both look like some sort of paintings, don't they? And these are images that have been processed by citizen scientists from the Juno data. Just give you, you know, what you're looking at there are storms, essentially, swirls in the atmosphere of Jupiter. And just go back over a couple of the previous images that I particularly like. This one was taken, I think, in July this year, and it shows Jupiter with the shadow of Ganymede on its surface, which is that big black spot. It's not like in 2010, where Jupiter gets consumed by the monolith and turned into a new star. This is actually the shadow of Ganymede on the surface of Jupiter. And I'll just quickly run through these. Here you see a very dark storm. Nobody knows why it's so dark compared to the others. But, you know, these are continent-sized storms. These are absolutely enormous storms. Unfortunately, with these images, we don't have any sense of scale, but these are, you know, enormous storms. This one, again, much like an artwork, you can see how dynamic the atmosphere of Jupiter is with all these storms. And, you know, there's a long way to go yet to unravel exactly what happens and how they arise and, you know, what their properties are and how they behave and all of that. I love this one. This one does look like a work of art. And before Juno got to Jupiter, we had no idea of the complexity of this atmosphere, how dynamic it is with all these storms. Here's one of the Great Red Spot, which, you know, as we know, is much bigger than the Earth. And it's been around for a few hundred years at least, and has really interesting topography and features, and goes down a long way into the atmosphere as well. But again, it's something that we don't fully understand yet. There's another one there of these storms in the atmosphere. And this one is, the colors are just absolutely amazing. Yes, Daz.
I was just asking, are these storms that you're showing, are they the ones at the poles?
No, these are all over the planet.
Oh, okay then.
Yeah.
Because I was just wondering whether the blue ones were sort of like they're similar to the ones we see at the poles.
They could well be, but don't forget that actually it's funny to say that this is actually the North Pole. This one is actually the North Pole of Jupiter. But of course, we've got one at the South Pole, which is this. Now, this is truly amazing. There's a single storm at the center surrounded by other ones. I mean, you know, it's been called the pepperoni planet because it does look a bit like a pepperoni pizza. And as you can see, the United States is shown for scale in the middle of that giant storm. How these storms form in this particular configuration, what maintains them, we don't know. There's a long way to go yet. It's going to keep planetary scientists bigger for very busy for decades. One thing that Juno was trying to answer is what's at the center of Jupiter. It had been suspected without any real reason that there was perhaps a solid core at the center of Jupiter, perhaps something the size of the Earth. And now we know that that's not the case, that Jupiter does have a solid core, but instead of being a dense, well-defined, discrete object, it's fuzzy. It's sort of spread out over a large portion of the planet. And one possible explanation is that Jupiter had a collision early in its life, which sort of shook it up a bit and sort of diluted the core. But the fact that Jupiter has this fuzzy core instead of a well-defined one is a real mystery, and you know, again, a lot of work to be done there. Another thing that Juno has enabled us to do is to map Jupiter's magnetic field in some detail, and there's a big shock about this, that the northern magnetic field in Jupiter is completely different from the one in the southern hemisphere. The one in the southern hemisphere wraps itself around the planet, and Jupiter's magnetosphere is absolutely enormous. But the magnetic field in the northern hemisphere ends in sort of strands, as in this image of the map of the magnetic field. And why the two hemispheres, first of all, have different magnetic fields instead of one global magnetic field is a real mystery. And also why the northern magnetic field, as shown here, is really weird. So, you know, a lot of head scratching going on here. Juno has given us this wonderful image of Ganymede that it took on a flyby at the beginning of this year. Coming up on this coming Thursday, Juno is doing a flyby of Jupiter's moon Europa. And that is occurring on Thursday, this coming Thursday, the 29th at 10:36 in the morning BST. We're going to get the first new images of Europa, close-up images, that is, in about 20 years since the Galileo probe. So we hope to see some really beautiful high definition images of Europa, the first such images in the next, in the last 20 years. So there's a lot happening this week, and we've got a packed program tonight. So later, Steve will be talking about something he witnessed on the sun at the weekend, wasn't it, Steve? You're muted, by the way.
It was indeed, yes.
Yeah, okay, well, we'll save that for later. Lou is going to carry on with his wonderful series about exoplanets. We'll have Roger's night sky, as always, and Roger, you've got some new JWST images this week.
I do, yes.
Superb, yep, so we'll be seeing those. Rachel, welcome back, Rachel. I haven't seen you for a while, but you're very welcome back.
Thank you.
Rachel will be giving us the viewers gallery, so if you sent images into Rachel, hopefully you'll see them tonight. And Bernard, welcome.
Yeah, thanks, Andy. Thanks, Andy. I just wanted to quickly barge in just to remind everyone that the images taken by Juno are from a camera that was repurposed from the Curiosity mission, which was the Mardi camera, just a leftover from the Curiosity buildup. And it's basically the descent stage camera that Curiosity used in order to land on the planet, and they took one of those leftovers and re-engineered it to attach it to Juno. So all these amazing pictures of Jupiter and hopefully of Europa as well come from, an off-the-shelf camera that was left from a Mars mission. So that's just, extraordinary how they managed to build these things.
Absolutely. And as you said, it's really a citizen science camera.
Yes.
And tell us a bit about that. How come it's a citizen science camera?
So basically, when they designed Juno mission, they didn't actually because it was a fields instrument spacecraft. They didn't actually have any budget for any camera, basically any optical camera. And then it's when they were building the mission, the team said, "Oh my gosh! Like, we were going back to Jupiter, we actually need to have images." And because they really had no budget allocated for that, they just started to repurpose whatever they could. And it's called a citizen science camera because there's no budget for the processing and development of the images that are being sent back by Juno Cam. All the images are immediately sent unprocessed into a database that everyone has access around the world. And so even those images that Juno is going to take of Europa are going to be immediately going onto that. All these raw images are going to go immediately on that database, and that's just phenomenal. I mean, we're going to have images of a moon, amazing moon. We haven't taken pictures of in 20 years, and we'll be able to really get those images straight away and process them. Anyone in the world. Don't we live in extraordinary times?
Yeah, we live in amazingly exciting times. So, but just out of interest, Bernard, do you know the best website that might be covering the flyby?
Actually, no. I would presume NASA. I can definitely do some research on that and put it on the YouTube channel while we're talking.
Absolutely,
I'll do that. That's a good point.
Fantastic. I've just got one more thing that I want to share before we move on to somebody else. So let me just share my screen. Okay, so this is the ALMA telescope high up on the plains of the Atacama Desert in Chile. ALMA stands for the Atacama Large Millimeter Submillimeter Array. It's a radio telescope that's giving us exquisite images of distant objects, of planetary disks, all sorts of things. But it's made quite an amazing discovery this week, which concerns the black hole at the center of our galaxy, which is referred to as Sagittarius A star. And what ALMA detected was a huge glob of gas orbiting the black hole at the center of our galaxy. Now, we don't have they haven't released any actual images of this, but what we do know is that it was a fortuitous discovery, because this glob of gas orbiting Sagittarius A star probably only lasted a few hours. And the reason it only lasted a few hours was because it was traveling so incredibly fast around the black hole, completing one orbit in about 17 minutes, that it would have almost inevitably been torn apart by the black hole's gravity within a few hours. And the only thing I wanted to say here was that it was going at a speed of 200 million miles per hour, just over. And this is 30% of the speed of light. So this glob of gas was traveling around our local supermassive black hole, 26,000 light years away, at 30% of the speed of light. Now, the interesting thing about this is that just a couple of weeks previously, astronomers had detected an X-ray flare from the vicinity of the black hole, which they think was another glob of gas being torn apart by the gravity, heating up and generating immense quantities of X-rays. But this is the first time that such a blob of gas has been seen at radio wavelengths. We normally only see them in the ultraviolet and the infrared and the X-ray wavelengths. So what this means, nobody's quite sure yet, but this is the first time that such a blob of gas around the black hole has been observed at radio wavelengths. So I just thought I'd share that with you. 200 million miles per hour is just, to me, that's an...
Yeah, the X-ray bursts are all caught by the Chandra
that's
space
right.
telescope. Yeah,
the Chandra telescope.
And now they think they are actually linked. And as you said, the speed is phenomenal. It's absolutely fantastic. It takes 17 minutes to go do a complete orbit? So fast.
Yeah. So you know, anything traveling at that speed is going to be, especially something as tenuous as gas, is going to be ripped apart, you know, extremely quickly. So there we are. So that's just a few interesting things that I came across in the news this week. Steve, tell us what you've been up to, because you saw something amazing. You're muted.
I'll just share my screen. So that's where I want to be. I'll just put it into slide mode, and hopefully that will be visible to you.
It's coming. There we are.
Good, good. Well, good evening, everyone. This last weekend, I was out on the island of Anglesey, having organised, as I do every couple of months, a dark sky field trip for my astronomy group, Macclesfield Astronomical Society, MacAstro. I'm just going to show you, just for a few minutes, something that was particularly memorable, put it that way. We were blessed by the weather gods. We had a couple of really good evening skies, really good dark, very crystal clear skies. But this was something I saw on the Friday afternoon. I'll just show you, these sketches are very rough and ready, so forgive me. This is roughly what I remember, because I've done these today, having made some very quick notes at the time. This is roughly what I remember the surface of the sun looking like. The light sort of yellowy areas are plages. Those are more active areas of the sun, and they tend to look brighter in a solar scope. I'm lucky to have acquired a while ago quite a good solar scope, and it's often in the middle of plages that you get sunspots. Hopefully you can see this is a rough indication of the sort of sunspot groupings that I could see at the time on Friday afternoon. But also around the edge of the sun, you see prominences, and these are the prominences I noted down just to make them a little bit clearer. There you go. These are quite a few all the way around the edge of the sun, because the sun is getting more active at the moment. That will increase for the next year or two. But these are fairly typical, the sort of prominences we see. Some of these may be. These are gas trapped in ionized gas trapped in loops of the magnetic field coming out from the sun generally. Some of them could be over the horizon, and we're just seeing the tops of them. So if I go back to that image and just look at the surface again, and these darker areas here are what we call filaments. These are actually prominences on the surface that we're looking down upon, and in the solar scope view they often look darker. They tend to look darker and sort of snake-like. Quite sinuous. But the reason I'm showing you this particularly, because this is a fairly typical view of the sun. When I first set my solar scope up and looked in the eyepiece view, this is what I saw. This enormous eruption.
Wow.
That's huge.
And I gasped and shouted out, "Whoa!" to everybody. Come and have a look at this. It was clearly a coronal mass ejection. It was probably 3 times as big as I'd ever seen in my solar scope before, any prominence. And just to show you, if you look to the left of it, that little dot over there is the size of Earth, I reckon, roughly by comparison. In fact, I reckon it was roughly a third of the diameter when we first saw it, pretty much 35 Earths across. An enormous thing, and it developed very quickly. About 5 minutes after it was purely chance that I just happened to get my solar scope up, having been out in the morning at exactly the right time to see this. After about 5 minutes, it had developed a little more, and most of the gas had detached there. And after about 10 to 15 minutes, although I was looking at the view, not at the time, it had roughly moved out. So this was then moving a coronal mass ejection of plasma gas out into space. Andy's gas around the black hole was traveling about 200 million miles an hour, I think, something like that.
Yeah.
This was traveling at about 2 million miles an hour, roughly, because it takes, if it were heading our way, of course, this is what causes space weather, auroral activity to increase. And they tend to come out to us, I think, in about 2.5 days, something like that. But that was the highlight. There were a couple of other things that subsequently took place. I discovered, I've noted this before, actually, when the sun gets really quite low to the horizon, as long as it's a clear day, you get much more contrasty, bright, contrasty views. And that prominence up there, which started off as this very long but fine tendril of a prominence, had developed more into a mass like that, with a sort of like a snake, a snake's mouth on the end of it. And literally within about 5 minutes, had reconnected back to the surface. So these prominences can change remarkably quickly within view. And the one down there was quite extensive, but quite considerably fainter than the others, but still very evident. That developed into something, again, much more contrasty later in the day and much more extensive. So there we go, the general view of the sun, but not to forget that as well as the weather gods enabling the view, the solar weather gods enabled us to see that fantastic.
Oh, that's fantastic.
It's not often that happens.
Yeah, that's fantastic, Steve. Thanks for that.
Yeah.
I must just, oh, sorry, Andy, just a quick one. I must put forward, never point a telescope at the sun without the proper protective equipment. I see we've got Mr. Mark Thompson in the chat. He has an excellent video on YouTube of what happens if you look through a telescope. He uses, I think it's a pig's eye or a bull's eye, how quickly it will burn your eye out. So just remember, never point a telescope, anything with a lens or glass or anything like that, at the sun without the proper equipment. I just wanted to put that out there.
Thank you, Taz. You're absolutely right. Don't look at the sun with sunglasses. They are nowhere near good enough to cut out most of the damaging wavelengths. Solar telescopes, are very specialised, very worthwhile, but generally quite expensive pieces of kit. So I've only acquired mine much later in life, over the last few years.
Yeah, Steve, that what I saw on Saturday afternoon was about the 4 o'clock position, like the one that you chose, and it was through a Coronado solar telescope, and it looked like a darkening of the disk, and a sort of V shape. And I was told that was the prominence that I was looking at directly on the actual disk. So yeah, and that was Saturday afternoon.
Can I just bring Lou in on this, because I know this is sort of your area of expertise, Lou. Is such a prominence, like the massive one, Steve, is that unusual during this period of the sun's cycle? You're muted, by the way. Because it did seem incredibly huge, Steve.
Oh, it was, honestly, it was breathtaking. I'm not too methodical about observing. I just look at the sun when it's nice and sunny, and I'm able to get the equipment out. But this was just of a scale I've never ever seen at all.
No. Oh, Lou's gone.
Am I coming through now?
Okay.
Yes, we can hear you, but not see you.
Ah, wonderful. Yes, this kind of solar activity, as we're heading up towards solar max in a couple of years, you're going to see not only increase in the number of sunspots, and of course these solar storms tend to occur over large sunspot regions, but much more intense activity above these. Now, the absolutely amazing CME or flare that you showed in your drawing, that was headed out to the side of the solar system. That one won't hit us. But when they occur around sunspots closer to the center of the disk, then they can really cause some real problems here on Earth, headed right at us.
Yeah, Ian
Oh, by the way, Lou,
McIntyre.
we can hear you, but we can't see you anymore. So,
Yeah, Ian McIntyre said, "Glad it wasn't coming at us." So,
Yeah.
There we
because
go.
it causes
There you go.
does cause
There you
problem
are.
with radios.
yeah,
and
because
things like
when
that.
these things hit the Earth, they have the potential to knock out power grids, satellites.
But they give us what's behind you, Andy.
Yes, they produce what's behind me. So
The lovely
we
aurora.
love
Yeah.
it.
Yeah, but there's also the famous Carrington event, which knocked out a lot of made a lot of issues on the infrastructure.
Yeah, 'cause
Hopefully,
it's-
that was 120 years ago, something like
Because
that.
they were just getting into Morse code with the old tappy tappies,
Telegraphy,
and they'd formed
Is that the technical name,
stations throughout the America. And when the storm hit, the actual operators were getting electric shocks from their equipment.
Blimey.
So it was the first time we sort of like really realized that these things and he had noticed that the flares had happened a day or so before. So, and he put them two and two together, and then that's how they realized that these events can affect us, affect electrical stuff and things like that. And it can cause a lot of damage if we get a big one hit us sometimes. So
Right.
Yep.
They found newspaper reports of aurora from the Carrington event as far south as South America. And of course, there were no integrated circuits then. There were no satellites. If something like that happened today, there are papers out on the kind of economic damage it would do. I think Jim Green and Stan Odenwald, I think, produced one of those papers, and it would be in the many, many billions of dollars.
Yeah, absolutely. Right. Well, moving on. Just before we come to Lou with his little bit about exoplanets, I will be announcing the details of the competition to win a telescope a little later. But before we do that, tonight is another big event. It's the culmination of the DART mission tonight. So, Michael, can you tell us a little bit about that?
Yeah, I can. If you just bear with me a second. Hold on. I'll just get my slides. I'm going to share my screen. Can I share my screen? Oops. Okay.
We're not
Can you
seeing
see that? Can you see that?
We did.
That's it.
Got it? Okay.
Yeah.
Okay. Yeah. So this is the DART mission that's culminating, as Andy says, in an explosive finale tonight. DART is aimed at an asteroid called Dimorphos, which is about 9.6 million kilometers from Earth. And it's a satellite, diameters across, and it's a small satellite of another asteroid called Didymos. What the NASA scientists are hoping to achieve is that if we sent a satellite to smash into an asteroid like this, it would be able to change the asteroid's motion into a different orbit than it is at the moment, just by using the kinetic energy of the impact of the satellite into the asteroid. That is the main idea. I'll just change this. Here's the diagram of the system itself. Dimorphos, as you can see there, is the satellite of Didymos, much smaller. DART spacecraft will be impact Dimorphos. The DART spacecraft has a companion spacecraft as well, if you like, called the Lucia Cube, which will also observe the impact locally in the orbit of the asteroid. But the main observations will be done from telescopes around the world on the Earth. and to determine if the impact has caused any difference to the orbit of the asteroid. A few weeks ago, the DART mission took photographs of Didymos. Not very big in the frame there, but just to say that they were ready for the impact that's actually coming up tonight. To watch the event, probably the best website to go to is the Johns Hopkins University Applied Physics Laboratory DART site, as they're actually controlling the mission. And this was a shot of their website about half an hour ago. So it's actually happening live overnight tonight, between 11:30 tonight UK time and about 1 o'clock in the morning tomorrow on Tuesday. So if you want to stay up and watch it live, you can do. So
and it's also being carried by the NASA Live website, which you can also go to. So great. So we're all excited to see what happens.
Daz wants to say something.
Yeah, the actual time that they're predicting for impact for us in the UK is the early minutes of the morning, which is 17 minutes past midnight,
right,
on the 27th, and EDT, that'll be 1917 EDT.
Right.
So yes, it's being covered by several companies on YouTube, and of course NASA Live will be probably the easiest to find, but NASA Space Flight and others will also be doing exactly the same. Join in the chat. I think they're starting in the NASA Live about 3/4 of an hour before the actual impact. And it will be covered live. As Michael said, it's going to be photographed and filmed by the CubeSat. So almost, Andy, how far was it? Do you say it would travel to the signal?
It's it wasn't much. Hang on.
No, it's only a matter of time.
I'd just like to say as well that the TV broadcast, the TV news broadcasted about it earlier, they just had to start with a clip from Armageddon, of course.
Oh, no.
Yeah, a lot of the things have got, and of course this is why they're actually doing it. It's to do with the planetary defense of against near Earth objects. And what we're talking about is asteroids. We've always got asteroids coming around us. They've got all different types of orbits. They're elliptical. They're inclined at different angles. And we usually classify them as a Tyre, Apollo, Athens, or Amores. And this is all determined by what sort of orbit they've got. And the ones we need to be concerned more about are the Apollo ones. They come closest to Earth and they will cross the path of Earth. But the asteroids can move between these categories, because at different times, as I said, they're all inclined, they're elliptical, they're lots of, some travel far out, some are closer, some are just inside our orbits and things like that. So that's how they're designated. There's a lot more science behind it than that, but we won't go into that.
And of course, it also goes back to the dinosaurs, the demise of the dinosaurs.
Yeah, they're to blame.
Because we now realise that it could have been a large asteroid that hit the Earth that caused the devastation of the planet.
It's supposed to have been around. What they think the impact crater is basically the Mexican Gulf. It's Chicxulub. Sorry if I've murdered that. But I mean, we've always had impacts. The reason we're doing this is it's a proof of concept. That's what we're trying to do. As I said, we've got the planetary defense against near Earth objects, and we've got several different ways that we're going to try out to see if we can deflect objects. There's one of them, we're going to paint them. Get out there with a spray gun, paint it so the sunlight will deflect it. There's also one where they're talking about possibly putting little engines, rocket engines on there to push it to one side. Are
we not sending Bruce Willis as well?
He's already up there, mate. He's up there.
Yeah.
He's sorting it. He's sorted. But
it's important to say for this, though, that this asteroid does not pose any risk.
That's right.
No, that's right. This is just an experiment only.
We're not.
There is no
danger.
Yeah, there is no immediate threat. It's just to prove. I mean, you can go online, and if you look for the US protocols as regards these sort of things, they have got contingency plans. There's usually 7 things. They're talking about detection. They're talking about notification of the rest of the world. They're talking about what decisions will be made, how they're going to try and deflect them, or some people are talking about just fire nuclear rockets at it, but we don't know what effect that's going to. It's just a proof of concept, and we're just going to see whether or not we can do it. And there's a whole host of things going on to try and mitigate these, but there is no threat at the moment at all.
But there will be one day. I mean, there will be an asteroid threat to the Earth, because it's happened throughout history.
Yeah.
But please, viewers, don't pay any attention to the tabloid rubbish. I think it was the Daily Express in Britain that over a period of 3 months the year before last carried 68 asteroid scare stories.
Oh, right.
And it seemed to be with the Daily Express. When it's slow news day, what we're going to write about? Oh, let's make up some nonsense about an asteroid threat. So please,
in the words of Douglas Adams, don't panic.
Yeah, exactly. Okay, let's move on. Lou, tell us a bit more about exoplanets.
All right, let me share my screen here. Let's see. By the way, they say, sports is a game of inches. Sometimes astronomy is a game of minutes. If the Earth had been 1 minute faster or 1 minute slower in its orbit 65 million years ago, the dinosaurs might not have been wiped out. Then where would we be?
Yeah.
I hate when that happens. I hate that.
Yeah.
Okay. So a little bit further from home here now, continuing on with our series on exoplanets, we kind of ran through a number of the ways that we detect these things, these exoplanets, and we're detecting more and more every week. I go to the NASA exoplanet archive, and there are always a few more exoplanets that have been confirmed. So doing it by the numbers right now, we have, you can see my screen, yes?
We can't see the slideshow. We can see the slide sort, but not the slideshow.
All right, let me try this.
It's just to make it a bit bigger, really.
How about that?
No.
I see it here on my screen.
Now it is. Yeah,
it's gone there. Yeah.
Okay. So just a recap by the numbers. We know a little over 5,000 planets confirmed around other stars, and many more that are candidate exoplanets that have yet to be confirmed but are suspected. And you can see here in this table just which missions have contributed to this. We have the TESS, Kepler, all these observation campaigns that are trying to find planets around other stars, because it helps us to answer this ultimate question of are there other Earths out there, and are we alone? So going back to this, you've seen this chart before. This is the progress that we've been making in detecting extrasolar planets, and the color coding here tells you what method was used. And because you have been faithfully following our exoplanet series, you know exactly what that means, whether it's radial velocity or transits or astrometry. And so no need to go over this in too much detail. You are already experts. So we haven't really talked about kind of the populations of exoplanets and how they that we've discovered so far. So I have a few plots here. By the way, these plots came from NASA Exoplanet Archive, and you can find these as well. So here's an interesting set of data. On the bottom, on the x-axis, is the period in days. In other words, the orbital period of the exoplanet. And along the side, on the y-axis, is its mass in Jupiter masses. So this would be one Jupiter mass, that the exoplanet would have the mass of essentially of Jupiter. 0.1 and 10, this is a log scale. And then the orbital period. Okay, so Earth's orbital period, 365 days, you know, somewhere in here. And so what you're seeing is a lot of fairly massive objects that orbit their star fairly quickly. And many of these are what we call our hot Jupiters. These are Jovian type planets that orbit, many of them inside what would be the orbit of Mercury if they were in our solar system. And so the question was asked when we started finding these, of course, why don't we have hot Jupiters in our solar system? And we believe that Jupiter, in fact, along with Saturn, migrated inwards, and Saturn's gravity, just to be very quick about this, in this grand tack model of planetary motion, that Saturn actually pulled it back out. And this whole dance could be form the basis for another series. But it's quite likely that Jupiter was much closer to the sun than it is today. Here we have an interesting set of data. Now, most of these data points here are verifications from observations made by the transit detection method, the planet moving in front of its star. And so on the bottom, we have the mass of that planet in Jupiter masses. And on the side, we have density. So you can see now density in grams per cubic centimeter. One would be, you know, no rock at all, completely, you know, water and gaseous. Earth is at about 5. Let's put the cursor here, 5.5 grams per cubic centimeter. And the outer solar system is down around 2 or less, that kind of thing, where it's frozen ice. So you can see that we have an awful lot of say Jupiter mass objects that don't have a lot of density to them, right? And so they are gas giants. And of course, you see some other data points from other observation techniques. In this graphic, we can see the orbital period versus the radius data, comparing it to Earth. So data falling along this line of these 5,000 or so data points would be about the size of Earth. And the challenge, the holy grail, so to speak, is to find Earth-sized planets orbiting in habitable zones around their stars. And so you can see, yes, we know of some number of roughly Earth-sized planets, but most of the things that we have detected, most of the exoplanets, have been larger than Earth. And we've talked about why that's the case, because the transiting detection method has been most widely used, and it's much more sensitive when you have a big object moving in front of the star. So, as I said, there are over 5,000 identified exoplanets, and I can't show you everyone, but I have 3 that I thought I would just highlight. And these are 3 of a number that orbit in the habitable zone of their star and are somewhat Earth-like, we think. Okay. The first one here is Kepler 186F, and as you remember, F is the designation of which order exoplanet it is. So this is a multi-planetary system. The star is a red dwarf, M1 spectral class, if you all are into spectral classes. We can find it in the constellation of Cygnus. It's quite far away, 178 parsecs, and it has a surface temperature, I don't know, roughly half of the surface temperature of our sun, because it is a red dwarf. And what is interesting about some of these red dwarfs is they tend to be kind of flary. They have lots of the kinds of flares that we saw earlier today in those beautiful drawings of the sun. That can pose some risk to planets that would like to otherwise form life, but not all of them are so flary. The thing is that most of the stars, at least in our galaxy, and we suspect in the universe, are in fact red dwarfs. It doesn't take much mass to create them. They live a long time. They don't burn their fuel so fast. So we're going to see a lot of planetary Earth-like candidates around red dwarfs. This is the Kepler 186F comparison. It's fairly close to the size of the Earth. And if we compare our 2 solar systems, this is our solar system here and the Kepler solar system, its planets orbit much closer to their star than to our sun. And you might expect something like that because its star doesn't have as much mass as our sun. And so you're going to find objects orbiting a little bit closer.
Sorry, Lou, can I just stop you? It's worth pointing out that is just a drawing of Kepler 186F. It's just what an artist thinks it may look like. It's not meant to be what it actually looks like.
Good point. Excellent point. Right. We cannot see these exoplanets in anywhere near this kind of, in most cases, we can't see them at all in terms of surface features, but certainly not this level of detail. That's a great point, Andy. Thank you. GC 581G, also a red dwarf, orbiting a red dwarf multiplanetary system, a little bit closer to Earth, 20 light years. And this red dwarf, as we were just talking about, red dwarfs tend to be kind of flary. This red dwarf appears not to be. And so this could be a great candidate of a roughly Earth-sized planet orbiting in the habitable zone of its star. And this red dwarf is fairly quiet. Here's another comparison of the two systems. First of all, in this square up here, I have Earth and Neptune, and something like this or so is the size of this exoplanet, Gliese 581. Which one was it? G, sorry. And then we have the Gliese solar system here, and we compared to Earth's solar system here. And once again, planets orbiting much closer to their star than our planets orbit our sun. And so the habitable zone is going to be much closer in to that star. And finally, I'll just one more, Gliese 667 CC. Now, we haven't talked about this designation. That's a little odd with 2 letters at the end. The reason is it's a triple solar system. There are 3 suns. Now, how you get a stable orbit out of that, I don't know. But this third star of that trio is a red dwarf, again, spectral class M1.5, and in the constellation Scorpius, and so on. And surface temperature a little bit closer to our sun. It's a super Earth, and we're starting to find a fair number of super Earths, a little bit larger than Earth, but smaller than Neptune. That's the criteria for super Earth. And it is orbiting in the habitable zone of its star. And here we see again the Gliese system on the top and our solar system for comparison on the bottom. And here we see all but 667 CCG are orbiting within what would be the orbit of Mercury. So once again, planets orbiting very close to their star. And a comparison on the side here of Gliese, again, and not a real image, but a size comparison, pretty close to Earth. And as our detection methods improve and our spacecraft improve, and as well as our ground-based observations, we're going to be finding many more Earth-sized planets around other stars.
Great.
And that's it.
Thank you very much for that, Lou. And we were talking earlier that astronomers may have come up with a completely new method of detecting exoplanets using the Lagrange points around stars. But we're going to let Lou talk about that perhaps next week, Lou, if you've got time to look at that.
Next week.
Fantastic. Okay, let's move on. Mentioned earlier that we, in association with Rother Valley Optics, who we'll be working with in future to bring you fantastic content, and we've got some ideas for some great stuff coming up here on Space Odyssey Live. We will be having a monthly competition to win a nice prize, and we're announcing tonight the first of those. And let me just share my screen. And we'd like to announce a competition, I hope you can all see that, to win this telescope, the Skywatcher Heritage 76, in association with Rother Valley Optics. It's a lovely beginner's telescope. It's a 76mm telescope, ideal for a child as a beginner. It's a reflecting telescope, and it has some pretty good reviews. So how can you go about winning this amazing prize? Let's have a look at the details. We'd like to announce a children's art competition. If you have a child who is 12 years old or younger, or you know somebody that has, perhaps they might like to enter an art competition to win that lovely telescope. So what we'd like the children to do is to draw a picture in any media of their favorite planet in the solar system. And we will judge the picture and come up with a winner. And obviously, as it says here, number 2, you can use any type of media except perhaps collages. We don't, want cutouts of planets out of magazines and things, but this has to be a drawing or painting or some sort of creative effort like that in any media. We'll take into account the amount of imagination, the technical ability, and of course, the children's age. And we have to say we're going to go by the International Astronomical Union definition of a planet. So no Plutos, please, because Pluto isn't really a planet, or at least it's not at the moment. When your child has done the drawing, take a photo of it. If you want to include your child in the photo, please do. But of course, if you're not happy for us to show that photo, then fine. But if you do include your child in the photo, obviously you entering the competition means that you give us consent to show that photo. So when you've done that and you've taken a photo of the image, your child's image, email it, number 3, to spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. And we'd like to announce the winner this time next week on Space Oddities. So please have your entries in by the end of this coming Friday, the 30th of September. And as I said, if you have a child who'd like to win that telescope, or you know somebody whose child who is 12 years old or younger, then, tell them to get drawing. In your email, please include the name of the child and their age. Also, please include a postal address. The reason we'd like a postal address is because every child who enters the competition, if they do not win, we will be sending them a small consolation prize. So everybody wins, everybody gets something in this competition. And we're going to announce the winner this time next week. Judges' decision is final, of course, and all of the entries will be shown on Space Oddities Live next week. And you entering the competition gives us consent to show the image. And as I said, if you want to include your child in the image, then please do. But again, your entry in the competition gives us consent to do that. So that's that. So this is the first of monthly competitions that we will be running with similar prizes. And we're very happy to do this, and very, very grateful to Rother Valley Optics for supplying the prize. And that's it really for the competition. Yeah. If you haven't got any of those details, you can always watch this on YouTube. Our live streams usually take about a day to be put up onto YouTube, so you can watch this tomorrow if you haven't got these details. But basically, get your child to do an image of their favorite planet. If you want to include a few lines in the email about why it's their favorite planet that we can read out, that might be nice as well, although that won't be judged as part of the competition. But it might be nice to know why your child has chosen that particular planet. Take a photo and mail it to gmail.com, include your postal address, the name of the child and their age. And as we said, if your child doesn't win, they will at least get a small consolation prize. So that's our first monthly competition.
There's a few in the chat, Andy, just asking, is this for UK only?
That's a very good question. Daz, do you have any thoughts about that?
Don't bring me into it. No, I should think just for this competition, we better say yes, because it's Rother Valley who's got to post-date the telescope. But if anybody does send entries in from elsewhere in the world, we will still endeavour to send them a consolation prize. And yes. We want to include everybody, and we want to get everybody out looking at the sky. As Andy said, this is a monthly thing. The prizes will vary, so also will the technical requirements of the people who can enter and things like that. So it won't always be children's events. It could be higher Absolutely. Up people in astrophotography and things like that. So keep your eye out. Good luck to your children. It's not just open to your children. If you know anybody whose child might want to win that telescope, get them to enter as well. And we're really thrilled to be doing this because we want to try and
excite young children about astronomy. They're all up to the age of 12 anyway. So so there we are. Okay, moving on. Time's getting on. So Rachel, you've got a few entries in the viewers gallery this week, I understand.
Yeah, we've got there's a small gallery this week, but yes, we've got some lovely entries. So let's I'll show you what we've got. Okay. So we've got one by Lee. Again, and I must say, just from watching how many Lee's sent through, he just seems to be getting better and better with every image he sends through. And this is 2.5 hours worth on the Heart Nebula, which is IC 1805, but he's named this one Peter in the Stones. And he says he'd like to call this nebula Peter in the Stones, proudly performing in the majestic night sky to the crowd of astronomers and astrophotographers here on Earth. So here is Lee's take on the Heart Nebula.
Oh, wow.
That's fantastic.
Wow.
That's Lee, that's amazing.
Yeah, wow.
That is,
it's really lovely. It's one of my favorite, if not the favorite, of my nebulas. So
that's amazing.
Yeah.
God well and truly smacked on that one, Lee.
Yeah, well done, Lee.
Well done, Lee. That's great work.
Then we've got one by Neil Barnes, and this is Andromeda and its little brother M32. And I'm sure, he said this is the first image of Andromeda he's ever taken. So he was in Wales for this trip, and he forgot everything he needed to connect his camera to the telescope.
Oh yes, I read that. Yes.
Yeah,
very good. Very good, Neil.
Yeah, excellent image, Neil. Thank you for that. That for a first image, that's not bad at all,
lesson learned there. Let the wife do the packing.
Like that.
And I don't like to have favorites, but when I saw this image, it just made me go wow. So here we've got one by Andy Weller from the Deerlick Galaxy. He's given us lots of information. I won't read it all to you, but it's often thought of the twin of the Milky Way, and it's a spiral galaxy in Pegasus. So
Oh
wow.
Yes.
Good grief.
I know, when I saw this, that's exactly what I said.
That is amazing.
Which is just, the colours, the depth. You feel like you can touch it.
The depth is amazing.
Yeah,
God, that's so clever.
Is that Hubble or James Webb? I can't tell.
Yeah, because it also looks.
That is really
that last one, Rachel. It also did look as though it's also got the sort of as you said, there's the kink, isn't there, in the disc, and it looks like this one's got it just over on the right hand side.
Yeah, it does, doesn't it? Yeah.
So it could be the twin of Milky Way. Yeah. Thanks for that, Rachel. Lovely. Thanks everyone. That was great.
And that was our short and sweet gallery this week.
Well, thank you all for sending those in. Rachel, I'm sure has already put the address to send your images in the chat. So get your images into Rachel if you'd like us to see them, and we do enjoy looking at them so much, as you can probably tell. We really look forward to seeing your images, and well done to everybody. They were 3 fantastic images, so well done to everybody.
And also, don't forget the people who are just doing basic DSLR thing. Get your images in as well. Get some nightscape images in. We want to see everything. We want to see everything. So
absolutely, absolutely. Yes, I mean, it doesn't matter how humble your equipment is. If you've taken what you think is a nice image, send it into us. We love seeing all of them. We really do.
I got quite a nice image of Mars with the Hades cluster and the other night. And as I said to Roger, actually in between the two of them, there is a cluster called the Pirate Cluster. So,
yeah, absolutely. Roger being our resident pirate, of course. And speaking of whom, last but not least, of course, we come to Roger's look at the night sky for this week. How have you been this week, Roger? Well, I hope.
Not too bad, not too bad. It's been a bit of an unusual phenomenon in the last week. I've had some clouds.
Oh,
no, really?
Yeah.
Shock horror probe.
What have
Stop
you
the
done?
presses. Yeah, stop the presses.
I don't know what happened there.
We actually had 2 days of intense thunderstorms here this week with tropical rain, and it was
wow.
I was outstanding in it. Just to the novelty.
We are outstanding in your field, then.
I was out. You're very quick tonight, Michael. What have you been eating or drinking? No, because after 6 months of virtually no rain, and clear skies. Sorry, guys. It's just wonderful to be out in the rain. Anyway, Roger, tell us what's up.
Okay, right. I have my usual weekly bits, plus a few other images from the James Webb and some new minerals discovered from the moon.
Wow.
Ooh, so there. Okay, here we go then. Right, so here we go for the 26th to the 2nd of October. Well, clocks will be going back at the end of that month.
Oh, don't.
Oh, no.
Less of that sort of language, please.
Right, so we're just coming out of the new moon, and towards the end of the week, we'll be getting the first quarter of the first quarter here. But while we're on the moon, we've also got some news of the new mineral known as changasite from the Chinese mission that landed earlier last year. Last year? No, 2020.
Year before.
And yes, chemically, it appears to be relatively more common phosphate mineral merylite, and is found in lunar and meteorite samples, which have also been found on the Earth. So that's an interesting thing, and it's one of only a few minerals also discovered from samples recovered from the moon, which has also been retrieved by the Russians and the Americans. So the Chinese are now picking up new minerals from the sites that they've also been visiting.
And I think, if I remember rightly, the size of that sample is absolutely tiny. So it was amazing that they found it in the first place.
Absolutely.
Yeah.
Lithium crystals, Captain.
So we've still got Mars and Jupiter. This was just taken a few nights ago. And tonight, Jupiter is at its opposition. And it's at its closest for about 57 years.
It's funny you should say that. I've read so many estimates. One says 50, one says 70, and I read another one tonight at its closest for 166 years.
Oh, right.
So I think it's between 50 and 60, isn't it?
Yeah.
Yeah.
So also still got Saturn up in the night sky. And here we are coming up through, and I'm having to put this on a wider and wider field of view while Saturn is moving away from Jupiter, and Mars is also becoming quite more visible. And this is at midnight. So Mars is coming up quite easily to view, and Jupiter's up quite nicely as well, although we are now starting to lose Saturn into the western horizons. Although there are some other little meteor showers. I've got southern Taurids up here as a matter of interest, so that may be of interest to spot that with a camera. And also down down under in the south, we've also got the winter constellations appearing. Orion is making a good appearance now, and Pegasus is now up, lowering itself down in the north. And we've also got Saturn way up, as also is Jupiter. So lucky old them.
Yeah, of course.
But
Mars
as a matter of interest, here we have some new images from the James Webb. And here we are looking at one of our solar system objects, which has also got some moons visible in the ring system. And that is the planet Uranus. Neptune, sorry. Yes. Of course, the big bright star up at the 11 o'clock position is the planet moon Triton, glowing away there. So yes, we've got some rather interesting images here with some of the moons
I'm super excited about this image because the last time any spacecraft went to Neptune was Voyager, and how now here we have JWST taking these amazing shots of the planet and the moons and the rings, and once again we're learning to rediscover this fascinating world. So thank you so much for sharing that, Roger.
Yeah, it's wonderful.
Okay.
And it's just worth pointing out that Triton was so very, very bright in the infrared, because basically it's ice and it reflects 70% of the light it receives. So it's very bright in the infrared.
Yes,
and of course,
pointing the Voyager iris infrared spectrometer at it in 1989, the data was pretty noisy, but we could put an upper limit of about 30 Kelvin on the surface temperature.
Right.
Yeah.
30. Wow, that's cold.
Yeah.
Isn't Triton the coldest place in the solar system? I think I've read that once.
It may be. I don't know how it relates to Pluto, but it.
You wouldn't want a holiday there anyway.
Before Pluto was.
It's not short weather there. Of course, because as you said, it's 70% reflection. It's albedo because it's all ice. Of course, Neptune itself is mostly methane, and that absorbs a lot of the near infrared. So that's why it appears that little bit darker.
Anyway,
70% reflection. That's a bit like your head, Andy, right? That's what we said earlier.
No, nowhere near. Mine's about 90% reflection. Bernard, you can go off people, Yeah.
We need eclipse glasses.
Oh, well, what is this? National Get It Andy Day? Yeah, thank you very much. Okay.
Anyway, we've also just got this brief spectroscopy readout of a distant galaxy here, just to get an idea of some compositions.
So a lot of peaks of oxygen there. And hydrogen.
I don't know what the aspect of the neon is. Do you know why we've got that highlighted, Lou?
I have no idea. I mean, neon exists in the interstellar medium and so on, but I don't know why we'd be seeing it. This looks like a fairly significant feature, so I don't know.
Yeah.
And that's not bad from 13.1 billion light years away, is it? That's an amazing feat to get a spectrograph of something that far away.
Maybe they shot it next to a neon sign or something that would
Hooters
that says something like "Last Coca-Cola for 200 light years."
Okay, well, that's what I'm showing for this week.
Thank you very much, Roger. Thank you very much. Right, just before we close today, just a quick reminder of the competition. Win this telescope, this lovely Skywatcher Heritage 76. It's the perfect telescope for a child starting out in astronomy. You can go look at the reviews, and you'll find it on the Rother Valley Optics website, of course, which is www.rothervalleyoptics.co.uk. We're very grateful to Rother Valley for supplying the prize for this month. There'll be another one next month, as we said. And just a very quick reminder, the email address for your entries, which is spaceoddities@gmail.com, and have those entries in by the end of this Friday, please, if you'd be so good. That gives us a weekend to put our collective heads together and judge the competition and to get everything organized. And we'll announce the winner this time next week on Space Oddities.
And don't forget Dark tonight, Juno Thursday.
Yeah, Dark tonight, Juno on Thursday. Jupiter's conjunction. You can't miss Jupiter in the eastern night sky at the moment. It's the brightest thing there. Look in the night sky, and the big bright thing you see is Jupiter, outshining everything else in the night sky quite considerably at the moment. If you miss it tonight, you won't see any appreciable difference in the brightness or image size of Jupiter for weeks. So don't worry if you don't see it tonight. We've got cloud here tonight, but I'll be out there with the telescope tomorrow, no doubt, if it's clear. So don't worry if you don't see it tonight. We'd like to thank you all very much for watching. We'd like to wish your children the very best of luck in our first Space Oddities Live competition in association with Walter Valley Optics. And we'd like to wish them the best of luck. And we're really looking forward to seeing the children's entries. And as I said, if they want to write a few lines about why they've chosen that as their favorite planet, that would be good to hear as well. Although, as I said, that won't be part of the judging, as it were. We'll be judging the image only. So thank you very much for being here. We've had a great time tonight. You all right, panel?
Yeah, we're fine. Don't forget to hit those likes, subscribe.
Yeah, like, subscribe, tell your friends, you know, ring people at random. You know, just do us the favor of publicizing us, because it's only by having more subscribers gives us more choices and more ability to bring you things like the competition. And we've got other plans for the future, which we think you're going to love as well. So we hope to see you back here next week, 8 p.m. UK time on Space Oddities Live. But for the moment, it's goodbye from the panel. Goodbye, panel. Have a great day.
Bye, everyone.
Goodbye,
everyone.
And we will see you this time next week. So from Space Oddities Live, bye-bye.